Okay, this is our UT Quest AP Physics assignment, Work and Energy. And one of your problems is an Atwood's machine. Now, we've studied Atwood's machines before when we talked about force and acceleration. Now it's asking us to solve this from a conservation of energy standpoint. And we're going to have to throw a little bit of kinematics in here. All right, so this is what we're given. We're given two masses and they're separated by a certain distance. So let's call this our zero potential energy level. Right there, there's our reference point. Well, here, this is at rest, this is at rest, so the only energy in the system initially is just the potential energy of this mass dangling above the other mass right here. That's easily computed. That's the easy part. The hard part is the final energy. The final energy, when I add them all up, it's got to equal this number, but I need the bits and pieces. Well, what's going to happen is when I let this system go, this mass is going to accelerate in this direction. This mass is going to accelerate in this direction, which means that this mass is going to gain potential energy. This mass is going to gain potential energy. This mass will lose potential energy. This mass will gain potential energy. And I have to take all those four things I just mentioned, add them up, and it has to equal this number right here. Okay? Well, how are we going to solve that? Well, this energy final has to equal this energy initial. What's it going to be broken up into? Well, like I said, this mass is going to accelerate, so it's going to have some kinetic energy. This mass is going to accelerate. It's going to have some kinetic energy. This mass is going to go up above my reference point, so it's going to gain potential energy. This guy here in the final state, it'll be down there, so the potential energy then of mass 1 will be 0. A little bit helpful, but we're still kind of in the hurt. Okay, so remember, this number has to equal this number. So when I get down to here, let's break this equation down into more specific variables. Okay, my energy initial, which equals my energy final, is 1/2. There's the velocity of the one mass. There's the velocity of the other mass. There's the potential energy gained by this little guy. Okay, well now I'm in the dilemma is I need to find these velocities. Well, I need to turn to kinematics. I know that initially this thing was at rest, and probably the most efficient way, there's other kinematics ways to calculate this, but this is going to get us right at V final, except I don't know this guy, acceleration. Well, now we go back to what we studied before in forces and acceleration, and we've studied Atwood's machines before. In the simplest way to think about an Atwood's machine is my F net is just a tug-of-war of the two weights of the masses is equal to mass times acceleration. Okay, so from here we can find my acceleration. From my acceleration, I can find my V final. Since my V final, these masses are attached, they have to have the same speed. So I know this, and I know this, so I can finish computing everything. Well, actually, what do I need to do? I need to solve for this, I believe. Wait one. Final speed. Yeah, my bad. So we need to solve for this guy. But that's our only variable that's left. Okay, that should get you good to go on this problem. Good luck.